All right, guys, let's do this. Let's go over these example problems. They're off of quizzes, but we didn't do them as quizzes from chapter 7, okay? All right, guys, whenever it asks you to find a general solution, all right, what that is asking you for is something, an equation with a plus c. So you're not finding the plus c, you're just saying it's an equation with the plus c. And then solve for y, okay? So step one, I got to split up these variables. Okay, this is called separation of variables. And I'm going to go ahead and take the integral of each one. So I get y to the third over 3 is x to the third over 3 plus a constant. Remember, you don't have to put your constant on both sides. You can just put your constant on one side. And then, whoops, that's not what I was looking for. There we go. Okay. Cool. All right, you guys, then what I'm going to do is I'm going to solve this for y. First thing, I'll multiply everything by 3. Okay, so this gives me y cubed is x cubed plus, now, if I multiply a constant times 3, it's still a constant. Granted, it's a different constant, so if you want to distinguish that, you can call it constant too, okay? And then I cube root both sides. For a cube root, you do not need a plus minus like you do for a square root. So it's just the cube root of x to the third plus c, or c2, okay? Perfect, okay? Find an equation which contains the point. Now, when it's saying a point, that's what you're going to use to find c, okay? Y prime, you guys, means dy dx. So I'm going to go ahead and separate these out. I need to bring the y down here. I need to bring the dx up here. Okay, so it's going to say dy over y is 2x dx. Integrate those both. Ln y equals, now you guys, 2x integrates to x squared over 2. The 2's cancel out. X squared plus a constant. All right, now, I don't know, sometimes I put the c in right here, and I do like that. Sometimes, especially if it's something easy to solve, I'll just wait and do the c in just a minute, okay? So let me just go ahead and solve for y. Now with an ln, remember we do e to both sides, because e to the ln just gives me absolute value of y. And so it's e to the x squared plus c. Okay, a couple of things, you guys. E is only ever positive. E cannot be negative without a negative in front of it. E is positive. So I can get rid of those. The other thing, we talked about this, but let's see if you guys remember. Let me put it over here. E to the x squared plus a constant is the same thing as e to the x squared times e to a constant. And that's simply another constant. Now, these are different constants. You could call that C1 and C2, but they're different constants. But we could basically put that constant in the front. So I'm just going to call it CE to the x squared. All right. Not the same C, though. That could be a C1. That could be a C2. Okay. So now, let me go ahead and use this point. Y, which is 2e, is CE to the 1 squared. So 2e equals CE. If I divide both sides by e, c equals 2. So my answer for this is y is 2e to the x squared. Okay? Okay, cool. Here's an extra problem. All right. Bring the dx up here. Bring the dy down here. So I have dy over 1 plus y squared equals x dx. Okay? A little bigger. All right, let's integrate both of those. This one, that's a thinker. I'm going to come back to that. But this one, I know that's x squared over 2 plus c. Okay, let's go back to this. Now it's a y, which is a little weird. We might not be used to seeing it like that. But are you guys used to seeing this? Anybody? Anybody? Are you guys screaming it at your screen? You should be. This is Arctan. That's Arctan, right? So, yeah, so this actually goes to arctan y. Just y, because it like follows the whole pattern. Okay? I could do the initial condition right now, but I'm actually going to wait and do it on my next step. Guys, in a problem, how do I get rid of an arctan? What's the inverse of an arctan? Well, guys, arctan is an inverse. It's inverse tan. So what's the inverse of inverse tan? It's just take the tangent of both sides. Okay, so check it out. Y, because tan of arctan, okay, equals tangent of x squared over 2 plus c. All right? At this point, yeah, let's go ahead and plug this in. 0, 1. So I want 1 to equal the tangent of 0 plus something. Whoops, get back over here. There we go. All right? Okay, so 0 is just 0. So I guess this is asking me the tangent of what equals 1? Tangent of what? Well, I know the tangent of pi over 4 equals 1. So my final equation right here is going to be y equals the tangent of x squared over 2 plus 4, pi over 4. And there's my answer. All right, finding the plus c. Cool. All right. Ah, yes. Slope fields. Okay. Just making sure everything's looking good as we move our way through here. Okay. Use a differential equation, blah, 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 draw a slope field. Okay, you guys. Notice, so it's y times x minus 1. So let's say I'm just going to like start along that row, right? Well, that's the point. Negative 1, 0, 0, 0, 1, 0, 2, 0, 3, 0. Do you guys see that in all of those y equals 0? And if y is 0, it doesn't really matter what x is. The slope is going to be 0. Okay? Okay, so that's cool. All right, this whole row, y is 1, which means it's just going to be the slope is going to be x minus 1. Okay. The x coordinate here is negative 1 minus 1. That's a negative 2 slope. 0 minus 1 is a negative 1 slope. 1 minus 1 is a 0 slope. 3 minus 1 is a 2 slope. And 1, 2, 3. Wait a minute. 0, 1 minus 1. 2 minus 1 is a 1 slope. Sorry. 3 minus 1 is a slope of 2. So it gets a little bit steeper right there. Whew. My brain. Now here where y equals 2, so I'm doubling the x coordinate minus 1. So negative 1 minus 1 is negative 2. 2 minus negative 2, it's negative 4. That's really steep. 2 minus negative 1 is negative 2. 2 times 0 is 0. That one's going to be 0 again. 2 times 1 is positive 2. 2 times 2 is positive 4. Hey, that's a good slope field. I like it. Okay, so now it says, on the same grid, sketch a particular solution through the differential. It contains the point 0, 1. 0, 1. Okay. And here we go. Looks like it's 0 right through there. And comes right back up. So there's my particular solution. Okay, solve the differential to find the particular solution that contains that point. All right. dy dx is y x minus 1. If I separate the variables, I need to bring the y down here, the dx up here, x minus 1 dx. To integrate both of them. So ln y equals x squared over 2 minus x plus a constant. Okay? Now, I was telling you guys, you could actually find c right here instead of like moving on. I think I'm going to do it on this one just to show you. Okay, so check out the point 0, 1. ln of 1 is 0 squared over 2 minus 0 plus c. Well, in this case, the ln of 1 is 0, so c is 0. Okay? So, right now, this is my equation. C is 0. I don't have to worry about that. I do, however, have to solve for y. And you know we talked about to solve for y with an ln there. I do e to both powers. Okay, so y is e to the x squared over 2 minus x. I would leave it like that with everything up in the e. I wouldn't try to simplify that at all. Okay, nice. All right. This one looks fun. Same thing, use the differential equation for problems 1 through 3. On the slope field, oh, they already made us the slope field. Wonderful. Do the particular solution through the point 1, -1. Cool. Let's see. Now, guys, how come there's no slope fields right here? It's undefined at that point, right? So I actually need to stop it right there and follow that. Okay. What that looks like to me. That looks like a square root upside down. Wouldn't it be interesting if this was a square root upside down? Be kind of cool. Okay. Oof. All right. Use Euler's method. Blah, blah. Let me see if I can remember. Euler's method goes x. Whoa, that was the craziest. Y. Dy dx. And then this, I remember, I like write it down. Change in y equals slope change in x. Okay, nice. Starting at the point 1, -1, a step size of -1/2. So if I subtract a half from that, that goes to 1/2. And if I subtract a half again, that goes to 0. And that's all I'm looking for. Okay. And I don't need like the last part of this. All right. So a lot of times what I like to do is where my dy dx is, I like to actually put my equation, -2 over y. Okay, so check it out. -2 over -1 equals 2. So the change in y is the slope times the change in x. And the change in x was a half. 2 times a half is 1. That's what I add to here. That gives me 0. Well, that's not good, because then dy dx is undefined right here. I do something weird, guys. Obviously, I did something weird. Down. Oh, I did do something weird, you guys. The step value is -1/2. Sheesh. Okay, because that can't happen. I mean, it can, but it would just be undefined. The step value was -1/2, so y went down by -1, so that's -2. Woo. I was a little bit worried for myself there. All right, next one. Dy dx is -2 over -2, which is 1. So the change in y equals 1 times the change in x. And 2 minus a half is -2.5, which tells me that y of 0 is approximately -2.5. That's a good approximate. Okay? Solve the differential to find the particular equation. All right, the differential was dy dx equals -2 over y. So I'll move that up there, that up there. So I have y dy is -2 dx. Okay, y squared over 2 equals -2x plus a constant. I'd at least like to multiply everything by a 2 first. Okay, if I do that, I get y squared is -4x plus 2 times a constant, which is just a different constant. Okay. I think at this point, I'm going to find c. All right, here's my point. When x is 1, y is -1. It's -4, 1 plus c. So 1 is -4 plus c, so c is 5. Okay? All right, let me come over here. I'm writing this weird. Okay, so I'm bringing this over here. Y squared is -4x plus 5. When I go to square root both sides, y is the plus or minus -4x plus 5. Now, we have to use this point one more time to decide if it's plus or minus. When I plug in a 1 for x, I get the square root of 1, and I want it to equal -1. So you guys, do I use the positive or negative? I have to use the negative because the y is negative. So I come up here, I pick the negative, that's my answer. All right, so that is how that works. Okay, cool. Shoot, this formula we saw a bunch on quiz 7-3. I will, as usual, probably not make you memorize that formula for the test, but I will have you memorize it for, you'll have to for the AP test, right? Okay. The carrying capacity is like that number right there. That's like the maximum. So remember the formula goes like this. Kp times m minus p, where that's the maximum or the carrying capacity. That's the constant. Okay, so find the carrying capacity on here. The carrying capacity is 300. All right, find the value of k. That's the value of k. So if you know that formula, it's just asking you for the parts. If the initial population is 50, find a formula for p. So you guys, this is my separating the variable step. Now, what this right here tells me means at time 0, there are 50 people. Time 0, population 50, p of 0 is 50. Those are 3 different representations of me writing the exact same thing. Okay, 0, 50, t equals 0, p equals 50, or p of 0 equals 50. This is the exact same thing. Just write it whichever way you want. All right, and now I'm going to separate variables. I did this so many times that one day, remember, and it was always partial fractions, okay? So I'm going to move this part down. So I'm going to go, okay, dp over, and I'll move this part up. 0.013 dt, not t, just dt. Okay? Integrate both. Now this doesn't say show all the work, so I suppose you could just go to the formula, but that's all right. All right. Did we realize that this was going to be every time 1 over 300? I think we did. If we let p equal 0, a is 1 over 300. If I let p equal 300, b is 1 over 300. So I think we did figure that out. So it basically goes back to the integral of 1 over 300 over p, and then 1 over 300 of 300 minus p. And then that is going to be the integral of 0.013 dt. Okay, so now I'm going to keep going. The integral on this side is 1 over 300 ln p minus, because of the reverse chain rule on that, minus 1 over 300 ln of 300 minus p equals, we're really running out of room here, guys. Get that out of the way. We don't really need that anyways. All right. That's better. Okay. Equals 0.013 t plus a constant. Let's do logarithm rules to get that, And do you guys remember that what we liked to do was multiply everything by -300, if only for the reason that it flipped these around and it made it ln of 300 minus p minus ln of p, and when I put them together, it's just easier to divide, easier to solve when it's like that. Okay, so on this side, it's going to give me, I guess I need a calculator for this, -300 times 0.013. That's a lovely number. So I got negative 3.9 plus a constant. Sorry, negative 3.9 t plus a constant. My bad. Do I want to find my constant right now? Trying to think. Yeah, sure, why not? Okay, I can find my constant right now. The point I'm plugging in is when t is 0, p is 50, okay? When time is 0, that means that's just a constant. P is 50. So 300 minus 50 is 250, divided by 50 is 5, so C is ln of 5, okay? So, ooh, you guys, this is crazy. Let me go back to this. ln 300 minus p over p equals negative 3.9t plus ln 5. Whew. Okay. To solve this, I need to do e to both sides. And so I get just 300 minus p over p. But at the same time, just save myself a little bit of space, I'm going to write it like this, okay? So 300 over p minus 1 is e to the negative 3.9t plus ln 5. I'm getting rid of that, okay? But if you remember, that's the same thing as, instead of saying plus ln 5, it's the same thing as times e to the ln 5, and e to the ln 5 cancels. So it's 5e to the negative 3.9t. I add 1 to both sides, 1 plus all of that. I solve for p by flipping it, so I like reciprocal this, put 1 over that entire thing, and then I multiply the 300 to the other side. Dang, guys. Whew, that's crazy. That was all for number 3, okay? So that's my population formula, but that's kind of the formula we know. When is the population growing the fastest? Do you guys remember it's growing the fastest at half of the maximum? Okay, we figured that out the other day because this is an upside down parabola, and an upside down parabola is like specifically maximizing right there at the vertex. Anyway, so it has to do with like negative b over 2a. At half the maximum is when the population growth is the fastest. So if the maximum equals 300, it's growing the fastest when the population is 150. But it doesn't ask me for what's the population. It says what time is the population 150. So I've got to use my new equation right here and plug in this equation right here and plug in a 150. Okay? Now you guys, we've done this so many times. Look, 150 equals 300 over negative 3.9t. But we talked about that in order to get 350 and 300, that has to be 2. You know, and you can cross multiply or whatever, but basically 300 divided by 2 is 150. So 2 has to be what's on the bottom. So if I subtract that over, 1 has to be negative 5e to the negative 3.9t. So if I divide by 5, that's 1/5. I ln both sides. Ln of 1/5 is, no, the ln gets rid of the e, is negative 3.9t. So I divide by negative 3.9. So the time is, whew, holy moly, ln of 1/5 divided by 3.9, negative 3.9, and I got 0.412. 6 or 0.413 years. Okay, let's see if that's the answer on the answer key. Let's go. It certainly is. Very good. Okay, find the limit as t approaches infinity of dp dt. So we're going back to here. Of dp dt. Find the limit as t approaches infinity of dp dt. Guys, I think that's a typo. Do you really want to say dp dt or the limit of p? Let's see. Well, the limit of p is 300. What's the limit of dp dt? A fair 0.013. Huh. Okay, well, let's try it. I have completely run out of room here, though. So let's find, we'll just go up here. All right. So the limit as hold on. What does it say? The limit as time approaches infinity. Okay. What's going to happen to this population as time approaches infinity? Let's think about that for a minute. The growth rate. Yeah. Okay. If we look over here, you guys, as time approaches infinity, this is what we know. It's going to become 301 plus e to the negative infinity goes to 0. So the population is going to approach 300. And what's happening is it's going like that, and it's leveling off the 300. So what's the rate of change of the population? Well, if it levels off, the rate of change is 0. I guess I just wanted you to think about that. Whew, that was crazy. Okay, here's some tips and stuff that we can talk about in class, but you guys can read through those. All right. And then I will do the next part of the review sheet in the next video.